Have you ever looked up at the stars and wondered, how did all of this begin? As we gaze at the night sky, this question often sparks our curiosity. Pondering the origins of the universe is no simple task. It's a question that has fueled many a scientific quest, driven by our innate desire to understand our place in the cosmos. This brings us to the topic of our exploration today, the birth of everything we know. Enter the Big Bang Theory, our cosmological attempt to answer this grand question. Imagine all matter, energy, space, and time condensed into an infinitesimally small point. This is the singularity. The singularity is a concept that challenges our understanding of the cosmos. Picture this: everything that exists, everything we see and don't see, all crammed into a space so small, you'd be hard-pressed to comprehend its size. In essence, that's what we're talking about when we say the singularity. It's an idea that belongs in the realm of the very large and the very small, where the rules as we know them start to break down. It's a place where our regular physics doesn't work, a place where even time and space as we understand them cease to exist. Why is this significant, you may ask? Well, the singularity is central to our understanding of the Big Bang Theory. This theory proposes that the universe as we know it started from a singularity. In other words, all the galaxies, stars, and planets, everything you see when you look up at the night sky, and even the vast stretches of emptiness between them, all of it began from this unimaginably tiny point. It's a concept that boggles the mind, isn't it? But remember, we're dealing with the birth of the universe here, an event of such magnitude that it's bound to challenge our everyday understanding. However, don't let the complexity discourage you. The singularity is not an end, but a beginning. It's the start of a cosmic story, a tale of expansion and evolution, a tale of galaxies forming and stars igniting. From this singularity, the universe was born, and life as we know it began its long journey into existence. And then, in an instant, everything changed. The singularity began to expand. This marked the beginning of the Big Bang and the start of our cosmic story. But that, dear listeners, is a tale for the next scene. The singularity didn't just sit there, it exploded, it expanded, it gave birth to our universe. Picture this, a moment so powerful, so cataclysmic that it's hard to even comprehend. This was the Big Bang. It wasn't an explosion in the traditional sense. Rather, it was the sudden and violent expansion of space itself. In the fraction of a second, smaller than the blink of an eye, the universe expanded from a point of infinite density and temperature, the singularity, to something vast and filled with energy. To truly grasp the enormity of this event, imagine a balloon. At the start, it's flat, uninflated, with all its points close together. Now imagine that balloon being inflated at a speed beyond comprehension, each point moving away from every other point, expanding in all directions at once. That's a simplified analogy of the Big Bang. But unlike a balloon, the universe didn't have a central point from which it expanded. Instead, the singularity that sparked the Big Bang was everywhere at once. And when it expanded, it didn't push out into something else. It was space itself that was expanding. In these first few moments, the universe was a hot, dense state of pure energy. So hot, in fact, that particles of matter couldn't even form yet. But as the universe expanded, it started to cool. And with this cooling, the first particles of matter started to appear. And so the universe continued to expand, to cool, to evolve, from pure energy to a universe filled with galaxies, stars, and planets, from a point of infinite density to a vast cosmos teeming with possibility. Now remember, this isn't just a tale of cosmic history, this is our history. The story of the Big Bang is the story of our origins, the beginning of everything we know. From this violent birth, our universe as we know it began to form. In the aftermath of the Big Bang, the universe was a hot, dense sea of particles. Let's paint a picture here. Imagine the universe as a cosmic soup, a stew of energy and fundamental particles. It was an incredibly dense, seething mass, hotter than anything we can comprehend, expanding rapidly. For a while, it was simply too hot and dense for particles to do anything but hurtle around in chaos. As the universe expanded, though, it began to cool, and as it cooled, things started to get interesting. The most basic particles, quarks and leptons, began to combine. They came together to form protons and neutrons, the building blocks of atomic nuclei. This was not an instantaneous process. It took about a millionth of a second for the universe to cool enough for this to happen. But once it started, it was like the universe had discovered a new trick and it was eager to show it off. For the next few minutes, the universe was a frenetic factory, churning out protons and neutrons. These particles were eager to join the party. They began to combine into atomic nuclei, creating the first elements, hydrogen, helium, and a smidgen of lithium. But even as this was happening, the universe was still too hot for these nuclei to capture electrons and form stable atoms. It was a place of constant flux, a dance of creation and destruction. It took about 375,000 years for the universe to cool enough for atoms to form. When this happened, it was as if a switch had been flipped. The universe went from opaque to transparent almost overnight. Light could now travel freely across the cosmos. The universe was no longer a chaotic soup. It was a sea of neutral atoms, and it was ready for the next stage of its evolution. Over the next billion years, gravity would pull these atoms into clumps, forming the first stars and galaxies. Over time, these particles would come together to form the stars, galaxies, and planets we see today. How do we know all of this happened? What evidence do we have for the Big Bang? These are excellent questions, and ones that scientists have been exploring for decades. Let's delve into two of the most compelling pieces of evidence that support the Big Bang theory. Firstly, let's talk about the cosmic microwave background radiation, or CMB for short. This is the afterglow of the Big Bang, a sort of echo from that initial explosion. This glow permeates every corner of the universe, but it's not something we can see with our naked eye. Instead, it's detectable as a type of radiation that fills the universe and is incredibly uniform in all directions. The discovery of the CMB in the mid-20th century was a monumental moment in science as it provided the first tangible evidence of the Big Bang. Now, on to the second piece of evidence, the redshift of distant galaxies. This is a bit more complex, but stick with me. You see, when we look at distant galaxies, we find that their light is shifted towards the red end of the spectrum. This is known as a redshift, and it's a sign that these galaxies are moving away from us. But not just moving away, they're accelerating. This suggests that the universe is expanding, and if you trace that expansion back, you end up at a single point, the singularity, the birthplace of the Big Bang. These observations align with the predictions of the Big Bang theory, lending credibility to the idea that our universe started from an incredibly dense, hot, singular point and has been expanding ever since. But remember, science is always evolving, always questioning. As more sophisticated tools are developed, we'll continue to probe the depths of the universe, seeking to understand its origins and its future. These pieces of evidence paint a compelling picture of our universe's violent birth. From a single point to an ever-expanding universe, that's the story of the Big Bang. We began our journey today by pondering the vastness of the cosmos. We dived into the singularity, an entity of infinite density and temperature that marked the inception of all existence. But it was the Big Bang, that explosive event approximately 13.8 billion years ago, which set the stage for the universe as we know it. In the aftermath of this cosmic explosion, the universe began to cool and expand, giving birth to galaxies, stars, and eventually, our home, planet Earth. Our exploration of the Big Bang wasn't just theoretical. We also discussed the compelling evidence that supports this theory, like the cosmic microwave background radiation and the redshift of distant galaxies, both pointing towards a universe that is not static but constantly expanding. The Big Bang theory, thus, is not just a story about the universe's past. It's a critical tool in our quest to understand the universe, its origins, and its future. It's a testament to human curiosity and our unyielding desire to decode the secrets of the cosmos. So next time you gaze up at the stars, remember the incredible journey our universe has been on since its explosive birth.